Our goal is to be the go-to body for hydrogen standards development. And to achieve that goal, it is important that industry feel like they have access to Standards Australia and feel like they can share what is needed when it comes to the standards that are required to support the industry. It is our intention to also be a trusted and reputable world leader in standards development, and our committees and the people in our committees put in a lot of work to ensure that the standards that get developed and adopted are truly a reflection of the product and the services and the quality that we want to produce in this space. So I've taken this slide from a strategic work plan that our ME93 committee put together a couple of years ago now. But what it does is it goes into detail around, hydrogen standards development, talks about our committees, our working groups, and talks about, the relevant committees that are also impacting or relevant in this space. So we have 5 different working groups working in this area and focusing on various parts of the supply chain. It might be a little bit hard to see, but we've got production, storage and handling, pipelines and gas distribution networks, end-use appliances, fuel cell applications and mobility use applications as well. What you'll find is the various standards that we've published and a summary of the objectives and also the use cases, which is going to be very useful for industry. We get lots of questions about, what standards have been published and where are Standards Australia at, and we will endeavour to ensure that we do keep our hydrogen page up to date with the relevant information because lots of work is happening. So we have a key role in influencing and actively participating in the international arena. Our MOU with the government encourages us to the extent feasible to adopt international standards and to foster international harmonisation. We are in the process of developing an international ISO standard on marine transfer arms for liquid hydrogen. And so this work is actively happening at the ISO level and hopefully will be available shortly. And what will most likely happen is, as we've actively contributed to that, we'll be able to then subsequently adopt that here in Australia as well. So there has been some standards mapping done to date, and this work is the work of the Future Fuels CRC to look at the standards and also regulations. This work does, though, talk about the work impacting the gas infrastructure, and also DISA are doing some work, and I know Amy will touch on that in her presentation after me as well.
So the National Hydrogen Strategy commitments about regulatory review are about improving hydrogen safety and ensuring consistency of those requirements. They are about improving the efficiency and transparency of regulatory approvals, ensuring that we have international competitiveness and consistency, and if possible, consistency across Australian states and territories, and of course trying to make our statute book adaptive to the rapid technological change that we are seeing in the hydrogen industry. Because it's a Commonwealth, state and territory project, the way that we have gone about undertaking our review is, instead of starting with the statute book, what we have tried to do is actually start with the activities in the hydrogen industry. We have identified model hydrogen projects that we understand either through our state and territory colleagues or industry engagement that industry is undertaking. We have developed a list of activities under each of those, very granular activities under each of those model hydrogen projects, which we think are all activities that a proponent would have to undertake to get to their end result. And then we have identified as any statutory instrument that we think would interact with that activity or analogous type of activity if there is no hydrogen specific or generic legislation that would apply to that activity. And this is intended to create a comprehensive hydrogen projects regulatory map. We have identified 6 model projects, and I think, like Amelia's slide, how you cut and dice these, depending on who you are and what you're up to, there's a lot of different ways to do it. But we have hydrogen production, refueling, transport mobility, electricity generation, use in production appliances, and export. So the hydrogen production facility project is relatively broad, and we have included in that, for example, things like a green hydrogen production facility and a blue hydrogen production facility. So that would necessarily also involve mapping statutory instruments that relate to carbon capture and storage. You can see there that the hydrogen refueling stations is about the transport of fuel to stations, potentially the production of fuel at those stations, bunkering, hydrogen fuel cell bowser or dispensing equipment, safety regulations and standards, and fuel quality standards and weights and measures. Transport and mobility, closely aligned with refueling, but this is more about ensuring the regulatory framework for the use of vehicles that are hydrogen fuel celled or ammonia fueled vehicles, in the very broad range of them, so passenger vehicles, heavy transport, primary production machinery, trains, and the maritime vessels. Electricity generation, and as we said before, the export of hydrogen. The export of hydrogen is a little bit broad, but not as broad as what this group today is discussing, and we have limited that project essentially to the getting it off the dock in Australia and getting it onto the dock on the other side, insofar as that relates to domestic regulation that may implement domestically the range of our free trade agreement obligations or other trading obligations that we implement domestically with regulation in Australia. And we consider in this regulatory space that there are a number of things that we can do to potentially remove barriers and improve efficiency in regulatory decision making and compliance and approvals for industry, if we, for example, simply do a better job of transparency and of mapping our regulatory compliance pathways for our industry. These are sort of the breadth of the options for improvement that we would potentially look at in terms of the assessment of our regulatory map. The development of standards and our understanding of what standards can help industry understand what their compliance obligations are or ensure a consistency of decision making is something that we're really interested in to inform our work. And in the regulatory space, we don't necessarily think that standards have to actually be called up in regulation to play a really important role in the regulatory compliance and approvals pathway to ensure, like I said before, some really key things that we think can contribute to regulatory efficiency, which is about consistency of regulatory decision making and industry knowing how their application for approval in XYZ is going to be assessed and approved. We have mapped our export project regulatory pathway. And the good news is that currently the regulatory export pathway for H2 and ammonia is quite simple and for the most part permit tariff free. And hydrogen and ammonia are not caught up in any of the sort of more complex Customs Act and Excise Acts issues that other goods might be. So there is also, so mostly hydrogen ammonia are not listed under any of the prohibited exports or the excisable or duty exports. We have a number of free trade agreements in place, particularly with our close trading Asian nation countries. There is a plethora of free trade agreements that now cover our Asian trading nations, and all of them provide a 0% preferential tariff rate for hydrogen. All of the country of origin regulations are in place for certificates of origin to be issued in respect of hydrogen. That means that people can access those preferential tariff rates in any of our free trade agreement partners.
There is two methods, obviously, on that everybody is aware of: the production of ammonia, which is our exporting pathway to the wind and sunshine out of Australia to our neighboring countries, or even further to Europe, but even to Americas. So it's pretty much the well-known brown sort of color production of ammonia is through the SME in Norway, which is the steam methane reforming. But on the right hand side, we've got the green ammonia production, which is same process of Haber-Bosch, just two projects that are currently obviously in a pipeline, the one in the South Australia in Kultana area, and the second one is the project up in Yarwun, in the central sort of Queensland area. And as you can see, the project in South Australia is to start first as a demonstration plant, and then to grow up to 1.5 gigawatt of electrolyzer. Within hydrogen utility, we managed to build our knowledge base, or we can call it even a data sort of bank of various standards and regulations that a producer or manufacturer of hydrogen and / ammonia had to have in terms to comply with all the regulations. So we had to go and identify each of the segments of the production, that either that being the electrolyzer, then being to a separations unit, or either be that with ammonia synthesis loop, or then the piping to the exporting facilities, which will be at the wharf or port, but also the transport, logistics and deliveries of packaged product, not just bulk, to various destinations within Australia, within the state, or even interstate in Australia. So from our point of view, for any future sort of player into this market or producer, manufacturer of hydrogen, it will be of utmost importance, if they can come to one point where they can get at least some, a list of, standards and regulations that they have to follow, they have to comply with. Now, being exposed to bulk liquids and bulk gases, in particular ammonia, and knowing that ammonia is actually the vector or the vessels that we will export hydrogen out of Australia, it will be of much importance, to understand, what sort of, regulations and what sort of standards we've got when we're dealing with ammonia. Just for example, for storage and handling of ammonia, the last time that standards was published was in 2003. So since 2003, so that's 19 years, nothing has happened in that area. So it's pretty much that from cradle to grave, we need to have these product stewardship, right, where we comply with all the regulations and standards, of delivering the product, the sunshine out of Australia in a most successful and a most safety way to any parts of the world.
The HES project is a world-first trial to establish international liquefied hydrogen supply chain. So the project is to produce hydrogen from Victorian coal and transport by tube trailer to Australia's first hydrogen liquefaction facility in Hastings. Liquid hydrogen is quite common in Japan, US, and Europe, and each country has their own regulation. For example, in Japan, we have High Pressure Gas Safety Act, and all industrial gas or liquefied gases, including the liquid hydrogen, are covered by this act. However, Australian standard doesn't cover liquid hydrogen. Safety distance between the storage tank and with other facility, it would be based on a modeling analysis result. So then layout design would be difficult, and it takes time since we need the discussion with regulators in each time. MDMT is a minimum temperature pitch impact test at cryogenic condition is not required. These materials are often used at cryogenic condition, and ASME, or Japanese High Pressure Gas Safety Act, allow us to use these materials in a temperature range of liquid hydrogen or liquid helium. Liquid hydrogen is quite new in Australia, so AS does not cover this temperature. So for future liquid hydrogen business expansion, I think AS should be updated to cover this temperature range.